Okay, so we'll kick off. So welcome to our first STLE Alberta meeting. Welcome 2021, 2022. Our first couple for sure will be by Zoom due to COVID stuff. And we will see if maybe our November one, we will see. At this moment, I'm not too hopeful, but there's still a chance so that we can be in person. Here is our executive as it stands at the moment. Again, if anyone's interested in joining our executive, we definitely welcome new people and new ideas. So definitely put your name out there. Today's presentation, we have John, who's going to be speaking on development and demonstrations of prototype ultra low viscosity heavy duty diesel engine oil. Next month on October 19th, we will have Prem Pal, and he's going to be speaking on the chemistry of fuels and lubricant additives and what they do for performance and the environment. The head office or STLE, they're looking for people for their meeting and the exhibit. So definitely put that out there, and if you have some ideas or suggestions, definitely put your name in there. Our website. We have our own Alberta section website as well as LinkedIn and YouTube, which you can follow us. This recording will be put up on there as well. Please confirm that you are on mute during the presentation as it is being recorded. There is a chat and a Q&A option in here. So if you do have questions or anything, please type them in there. And one of us from the executive will be monitoring that, and we will bring them up at the end. And then I'm going to hand this over to John and I'll let him talk about himself and his topic. So I'm going to stop my sharing. And John, you should be able to take over.
All right, thank you. I'll try share screen. I believe I want to start with this one. All right, just to begin with, can you all see? Can you see this presentation so far?
Heavy duty diesel engine oils.
Yes. Okay, good. Thank you. Thank you very much, Jacqueline, and thank you all. Pleasure to join you today. And I do hope you'll find the contents of this presentation interesting and useful for you. So we'll start with some information about myself, a little bit about the company I work for and what we do. And we'll get a little bit into emissions and fuel economy requirements for heavy duty diesel engine oils. We'll talk about how they're classified according to the API classification system. And then we'll follow that with a presentation that I delivered, a recorded presentation that you will see that was delivered to the STLE section in May of this year. And it is all about a prototype, novel prototype product, a 0W-20 heavy duty engine oil. Nothing in the market like that right now. And we've done some work to show you what's possible. And we'll follow up with a Q&A on that afterwards. So again, my name is John Pettingill. I'm a research and development product specialist, and I've been with Petro-Canada Lubricants since 2000. So just about 21 years. Next month, it'll be 21 years. My primary responsibility is the design, development, and qualification, field trial demonstration of our heavy-duty diesel engine oil products known as Duron in the market, as well as our automotive gear oil products, which are the Traxon line. For background, I graduated from Ryerson University in Toronto with a degree in chemistry in 1994. So between 94 and 2000, I had generally worked in the automotive business, mainly in the automotive paints business with Magna International and Chrysler in Canada. I'm a member of STLE and SAE as well. Now, a little background on our company, and if you hear sometimes different stories about things, it's completely understandable because in the time I've been here, technically I'm working for the third company, even though I've stayed under the same roof for almost 21 years. Originally, Petro-Canada was part of Petro-Canada. Petro-Canada Lubricants, I should say, was a part of Petro-Canada. Back in 2009, Petro-Canada as a whole merged with Suncor Energy. And we kept our brand name, but really the parent company was Suncor Energy. And it stayed like that for a while up until early 2017, when Petro-Canada Lubricants was actually sold to HollyFrontier. Now, we are in the HollyFrontier Lubricants and Specialties business, but it's a Dallas, Texas-based company. And to add a little confusion to that, HollyFrontier recently, I guess, announced that we're merging with Sinclair Oil, which is another American company. And this is all very new. The company should be called in the future HF Sinclair. So for now, we are part of the lubricants division in HollyFrontier Lubricants and Specialties, and that also includes other companies that have since been acquired after Petro-Canada Lubricants joined, and that is Sonneborn and Red Giant Oil. But our brand is still out there. We have a strong brand name, and that will continue. All right, now we'll get into the classification and some discussion about history of heavy-duty engine oils. Heavy-duty engine oils have been around, obviously, as long as heavy-duty diesel trucks themselves. There wasn't always an organized sort of classification, but API, the American Petroleum Institute, did come out with a system for naming and classifying what these lubricants do. And over the years, these lubricants evolve as truck engines evolve and emissions systems evolve as required generally by government mandates to improve emissions and as technology improves in the vehicles over the years. So our latest category is API CK4 and FA4, and we'll get a little more into that later about why we have a split category right now. But over the years, these do change, they do evolve, and they do get more complex, I would say, because heavy-duty engine oils have to do more things now than they had to in the past. And it depends, engines run hotter now, so we have to make them more robust for oxidation. In the past, there might have been issues with engine oils leaking, so they've had to address seals compatibility. Over the years, systems have changed. Engines started to make more soot for a while, so we had to start developing engine oils that handle soot better. So there really is a real evolution to the way engine oils are developed and what they have to do. Now, as I mentioned, one of the main drivers to improving engine oils over the years are emissions requirements. And generally, the main emissions requirements of concern are particulates such as diesel and fine particulates from the exhaust. But basically, sorry, I meant soot. If I said diesel, I'm sorry, but basically soot particulates. But the other major emission of concern is nitrous oxide. And so for both of those parameters, particulates and nitrous oxide, there has been a requirement to really reduce the levels of those that are allowed out your exhaust stream. So back in the old category, C, by the way, is the diesel category. It stands for commercial. Some people think it stands for compression, and they are compression engines. There is no spark like a gasoline engine, but C technically stands for commercial. And over the years, basically every generation that comes along, you just add a letter. So C is older than F, which is older than G. And by the way, that -4 stands for 4-stroke. So in the old CE category, you were allowed particulates up to 0.60 grams per horsepower hour. And you were allowed nitrous oxide levels of up to 6 grams of nitrous oxide per horsepower hour. So basically what I want to show you with this chart is that you go to the next category, that becomes more stringent. You go to the CG, and more stringent even so, and more and more and more, until now Now, you see CJ4 here, and I mentioned that CK4 is the latest category, but CJ4, CK4, and FA4, they all have the same very low limits of what is allowed outside of your exhaust stream. So they've tightened them up dramatically to the point where there may be 2% of the allowable amount that was back in the late 1980s. So diesel engines really have come a long way, or not just diesel engines, but diesel systems have come a long way to really reduce harmful emissions from the tailpipe. Now, it's not just engines and oil that are doing this. It's definitely not just the engine oil. The engine oil has to be compatible with the actual system. And they've employed a lot of technologies to enable vehicles to reduce the emissions like this. And so some of them are like a DOC, diesel oxidation catalyst. EGR is exhaust gas recirculation. And it's a complex sort of setup in the system where exhaust gases are actually recirculated into the engine, and that's all to reduce nitrous oxides. And it's not without its consequences. It makes more soot. And there are some other consequences that you have to deal with that, but it does reduce nitrous oxide. There's the DPF, the diesel particulate filter. And so that actually captures your particulates, and those things were implemented to help reduce particulate emissions. And then there's the SCR, selective catalytic reduction, that also helps to reduce nitrous oxides. So a lot of technologies have been employed over the years to reduce emissions. And if you've been around long enough to have seen trucks many years ago, and you see them taking off, say, from an intersection, and a big plume of black smoke comes out, that was because what used to be allowed was more particulates and more nitrous oxides. Over the years, the emission systems have implemented so much additional technology, which is why that they are running much cleaner now than they used to. So we're not going to spend too much time looking at this chart, but basically emissions and fuel economy are mandated to improve over time. And there's a lot of numbers here, but essentially, if you look at what the standards are for 2017, and then fast forward 10 years to 2027, regardless of the model, whether it's class 7 or 8 or low, mid, or high roof, basically you have your number here, and then in 10 years, you have to be down to what it is here. So just for example, a low roof on a day cab class 7, whereas you're allowed 104 grams per ton mile of CO2, that amount will drop. And same with all of these. The amount of CO2 emissions will come down, and OEMs will have to meet these requirements, otherwise face fines. And likewise, well, CO2 emissions are going down. The fuel consumption has to go down as well. It's only logical. You burn less fuel, you make less emissions. This will be enabled by improved technology. The same thing is going on with on-road vehicles, but this will be enabled by improved technology. There are some contributions that heavy-duty engine oils can make themselves, and we will get into that a little more here, but also in my presentation that will follow this. So again, for either medium or heavy-duty engines, on a gram per base horsepower hour basis, the emissions will need to come down. So you see from 2014 to 2027, there's a change here for these, as well as the heavy duty. They all will be falling, as well as fuel consumption, and there will be these requirements to meet these new specifications. So I talked about the evolution of heavy-duty engine oils and the technology that changes with them. And the specification, the current specification in the heavy-duty world, API specifications, as I mentioned, is CK4 and its lower viscosity equivalent, which is FA4. So FA4 is the new fuel economy standard, which enables fuel economy basically and essentially because it's lower viscosity. So lower viscosity oil requires less energy to circulate through the engine. And if it requires less energy, it'll burn less fuel, slightly less fuel. And again, we'll get into some of the specifics of that in the following presentation. But what is important to know is that the requirements to meet the FA4 standard and all the engine tests and the bench tests, the qualification that it has to go through is as rigorous, it's identical to the CK4 test. And if you're wondering, and you probably are, what's PC11 anyway, and why does it have this in parenthesis, is because before a new oil category is officially adopted by the API, it's given a proposed category name. So that's what PC is, proposed category number 11. And as I mentioned, for the first time, it was split like this. So PC10 was the API CJ4 category. So to get backwards compatibility, so API meeting the previous category CJ4, CI4, and CI4 plus, you are basically qualifying your oils to everything that the previous category did, and then some. So we'll get into a little of the specifics here. And EMA is the Engine Manufacturers Association. They requested the new category, and normally this is the way it works. They request a new category to be introduced, and this was back in 2016 to help meet government regulations requiring improved performance. Because again, the way a category change works is normally there's a mandate by the government, EPA, to make improvements in emissions. And these are all step changes. So the EPA, or the EMA, I should say, the Manufacturers Association, decide how are they going to design their vehicles so that they meet these emissions requirements. Will it require, as I mentioned, technology like AGR and SCR? And then it comes from there to say, these systems are going to change. What are we going to have to do to make sure that our engines are properly lubricated? And then they will work with the EPA and all the stakeholders, or the API and the stakeholders and engine oil developers like Petro-Canada to develop engine oils that will work in these applications. So driven by EPA and the National Highway Traffic Standards Association requirements to improve emissions on model year 2017 engines. So as I mentioned, this is the current category. It's been around since late 2016, and it was made in mind for 2017 and going forward. We don't know how long this category will last, but probably about 10 years before PC12 comes along, and then we'll see what that's all about. OEMs are looking for improvements in oxidation control. So how do we respond to that? Oxidation control. And the reason is these engines, as one measure to gain efficiency, they will be running much hotter. So you have a higher thermal efficiency. They're running much hotter. But what does that mean to the oil? It means it's much more likely to be prone to oxidation. So we have to develop our engine oils in consideration of that with improved antioxidants. Aeration control. You don't want too much air in your oil. Simply put, where there's air in your oil, you don't have lubrication. You want good oil with very minimal air content in it, because where there's metal to metal contact, you do not want air where oil should be. Shear stability is about how well your oil stays in grade. If you have for example, a 1540 product, all multi-grades like that are made with polymers that can actually shear down and thin out the oil and reduce the viscosity over time. So you want shear stability, especially if you're going to be moving to a lower viscosity oil. You can sometimes tolerate a viscosity drop from a high, in a high viscosity oil to begin with, and that can be tolerable. But if you're starting with a thinner oil, you may not have any room for shear down to a lower viscosity. And as well as scuffing and adhesive wear, that didn't make it as a technical requirement into the category, although oils are tested for it. And this is because OEMs need assurance that with a lower viscosity oil, that you could still provide protection that you would get with a higher viscosity oil. So we have a split category, as I mentioned, and it resulted in what we have today as API FA4 and CK4. All right, so thank you for your attention on this one. We will now move to my presentation that was delivered on in May to the STLE. I just want to make sure that you can hear the sound on it. And let's see, maybe share. Okay. All right, and so I will begin my presentation on the 0W-20, and then following that, we'll have a Q&A session.
Which screen should we be seeing right now, John?
Good afternoon, everyone, and thank you for joining me today. My name is John.
Do you see the one with my, it says development and demonstration?
I do not.
No.
Okay, so
I heard the sound though, John.
Pardon me? You heard the sound?
Yeah.
We heard the sound, just not the slide.
Okay, so here, let me share again. This one I'll close. Okay, we'll figure this out in a minute. What I think I need to get back into here, then I go share screen, share sound. I think this should work. Can you see it now?
Yes.
Yeah, there you go.
Okay,
Good.
Thank you. Okay, I will begin this slideshow that I presented to the STLE in May, and following this, we'll have our Q&A. And please just let me know if there's any issues going forward.
Good afternoon, everyone, and thank you for joining me today. My name is John Pettingill. I'm a product specialist with Petro-Canada Lubricants Research and Development Department, which is part of the Holly Frontier Lubricants and Specialties Group. Today, I'll be talking about the development and demonstration of a prototype 0W-20 heavy-duty diesel engine oil. So to start with a background on heavy-duty diesel engine oils, they are critical to providing engine protection and enabling longevity in heavy-duty diesel-powered engines. If it wasn't for high-quality engine oils, you wouldn't see these engines going upwards of 1 million or 1.5 million miles. So they are responsible for protection and long life. Some of their critical aspects are engine lubrication, of course, the primary one, but also wear control, sludge and deposit control so that the engine runs as it should, operating properly. These diesel engine oils have to provide soot handling, acid neutralization, and corrosion control to prevent corrosion and rust in the engine. They have to provide cooling of critical engine parts, and they've also got to maintain seals. But in addition to this, not just engine protection, but the engine oil itself must maintain performance characteristics. It's got to resist change in viscosity, so it doesn't go too much above or too much below its intended and designed grade. It has to control oxidation, which is more important now that engines are running hotter than they used to. It has to resist volatility at high temperatures so that it stays as a liquid. It doesn't go into the vapor state. And above all, it's got to maintain its function at wide temperature ranges. So multi-grade oils have to protect at very low temperatures as well as very high temperatures. So what's the case for the lower viscosity heavy-duty engine oil? Well, lower viscosity engine oils enable improved fuel economy. Now, the lowest viscosity currently allowed for API licensed and OEM approved heavy-duty engine oils in the market today in North America are the API FA4 products. Now they're available as 5W-30 and 10W-30 viscosity grades, and they're defined by their HTHS limits of 2.9 to 3.2 centipoise. So your HTHS is high temperature, high shear. It's a simulation of viscosity at high temperatures under extreme loading conditions. Now, by comparison, traditional heavy-duty engine oils need to meet a minimum of 3.5 centipoise or higher. But that depends on their viscosity grade or OEM requirements. So in some cases, those minimum requirements are 4.2 for, say, a 15W-40. So the challenge to us is, can we formulate a heavy-duty engine oil with viscosity below SAE 30 and FA4 limits and still provide strong engine protection? Well, in addition to fuel economy benefits, lower viscosity engine oils that maintain engine protection reduce vehicle operating costs, and they improve vehicle exhaust emissions. You're burning less fuel, so it's less emissions. So how do we know this? Well, within the engine oil business, there's general industry acceptance and agreement to the correlation of engine oil viscosity with fuel consumption, and that lower viscosity engine oil enables improved fuel economy. And even in the case of FA4 oils, which were launched at the same time as the most recent category of CK4, there was no actual fuel economy test that you had to run to demonstrate fuel economy capability of those FA4 oils, because the industry consensus is very strong. So where you have a higher grade with a higher HTHS, you will use more fuel in comparison with a lower grade having a lower HTHS. And depending on the application, it can, these differences from, say, a 1540 to a 1030 could be 1%, or 1540 to a 10W-30 FA4 could be up to 2%, sometimes even more. It's very application dependent. And of course, in the real world, it's everything keeping all other things constant except for the type of engine oil. But this correlation it's a good fit, and there's good industry consensus for this. So Petro-Canada Lubricants R&D has developed two prototype 0W-20 formulations for field trial evaluation. So we evaluated our products in a field trial. Now, just note that there are currently no 0W-20 heavy-duty engine oils that are commercially available in this grade and in the North American market. So the viscosity grade is defined by its kinematic viscosity at 100 Celsius. So the traditional grades that you're probably used to seeing are 540, 1540, or 1040, which are higher viscosity. And there's been a recent industry acceptance and OEM approval of the SAE 30 grade. So those include 530s, 1030s, et cetera. So we are testing even lower to enable improved fuel economy in the SAE 20 region. So our two test oils that we are going to show you our demonstration for are in this area here. But it's not that easy. There are formulation challenges. You don't want to just go into a test program or into a field trial without really giving some thought as to what you need to still protect the engine. So the main formulation concerns in this case are the low HTHS value, because this could risk oil film strength required to protect critical engine parts. And the base oil, the low base oil viscosity, that may also be a risk to film strength, and increased volatility of the oil under high operating temperatures and conditions. However, the risk has been alleviated in part with the use of proven performance additive technology that is common to API CK4 products. So you go ahead and design the oil but it's a very novel approach. And so the prototype 0W-20s were very carefully monitored with frequent sampling and testing through our used oil analysis program to check for critical performance characteristics during the field trial. So you want to make sure that these oils are going to hold up. And just looking at some basic formulation details, first of all, to eliminate potential bias when it comes to the testing, these were assigned test oil codes so that the people in the shop who were changing the oil in the trucks didn't know what these really were. And we assigned test oil names gray and beige to them. Now they were, because we're looking at two different 0W-20 formulations, they were equal in some aspects in that they both had the same base oil viscosity target and the same kinematic viscosity at 100. They both were made using group 3 base oils to meet the 0W and 20 requirement. And they both have the same performance package for additive technology. They differ in the type of viscosity modifier used. So test oil gray has a cone polymer, whereas test oil beige has a star polymer. Otherwise, the physical characteristics of what needs to meet 0W-20 viscosity requirements are very similar. Now, as I said, we did put these to the test, and they were really put to a severe test because we feel that if they can make it under really heavy conditions, then lighter loaded conditions shouldn't be a problem. Testing trucks were very similar to what you see here. ProStar International trucks equipped with Navistar Max Force and 13 engines. The routes were long haul routes with maximum loading of up to 140,000 pounds gross vehicle weight. This is considered severe duty. They use a high amount of fuel because they're so heavily loaded. So this really puts the oils to the test. And the testing site was outside of the Toronto area in Ontario, Canada. So the data that you'll see in the charts represents used oil analysis data, test results for duplicate runs of both test oils in similar trucks operating under similar duty cycles. So since you're not used to seeing data for 0W-20s, for reference, the field trial data includes data from an API licensed FA4 10W30 oil. And that was codenamed as test oil amber. So we have our two 020s, which are gray and beige, and then we compare them with amber. And just again, before we look at this, we see our gray and beige are 0W-20, our ambers at 1030 FA4. And the main base oil types for these are group 3 again, but mostly group 2 in the amber. And the test methods chosen were common industry test methods that you would often see in used oil analysis reports for any other similar projects going on. So tested viscosity, TBN, TAN, oxidation, and iron content according to common industry test methods. So the first thing we're going to look at here is the viscosity trend for these. So this is the region of minimum and maximum viscosity for a 20 grade oil. And the dotted line here is how the trend looks for test oil gray. And the straight line here is test oil beige. Now you can see that, first of all, the good news is that none of them fell below the 20 grade. So they maintained their viscosity, which is good because we're already going quite low on viscosity and you wouldn't want to risk engine protection by going any lower. However, test oil gray was better at maintaining viscosity control. And while test oil beige went above and into the 30 region. And this would be indicative that test oil gray would maintain its fuel economy benefits better than test oil gray because it didn't have the same thickening. And when you thicken into the higher grade, then you would expect that your fuel economy would not be maintained as well. What we're looking at here is our TBN and TAN trend. So your TBN is your total base number, your TAN is your total acid number. Now, we're looking at gray and beige relative to test oil amber here, which is the FA4 10W30. Now, with test oil amber, you can see that the base reserve was depleted much more rapidly than what we see with test oils gray and beige. And similar for acid increase on the 10W30 FA4 amber product, you can see that the TAN increase was at a higher rate than what we see here. So the good news for the 0W-20 products is that we don't see any rapid base depletion and we don't see any rapid acid increase. And it's interesting to see this. Field trials often tell you things that you might not have expected. But probably one of the key enablers for these strong attributes is that these 0W-20 test oils are formulated with high quality group 3 base oils, which most likely enables an improved synergy between the additives and the base oils in these products. The next attribute we're going to look at, which is very important for oil integrity, is oxidation resistance. So test oils gray and beige demonstrate very good resistance to oxidation. Lower is better. The lower you can keep it as your run progresses, the better your oxidation resistance is. So you see that they are directionally better than test oil amber, which is also, as we know, formulated with group 2 base oils. So this is another good sign that these 0W-20 oils are holding in just fine. Low resistance to oxidation, so the oil is not thickening, so the oil maintains its integrity, so that the additive package continues to do its job. Now moving on to one of the true tests, which is how well the oil maintains its resistance to wear, so to provide wear protection. Now, over time, any oil in an engine will show accumulation of wear metals. They build up as the drain interval progresses. And a very conservative industry limit for the amount of iron content would be 100 ppm. Some OEMs would say that's more conservative than you need to be, and they would allow a higher limit on that. But as you can see here, all these test oils, by the time we were approaching 50,000 kilometers into the run, maintained wear metal levels well below that. But particularly test oil gray maintained very good wear metal control. So here is the trend line for the existing licensed product, which is the FA4 10W30. But we can see slightly better wear metal control on the test oil gray, and then slightly higher wear metal accumulation on the test oil beige. There is no direct correlation here with HTHS and wear, because test oil amber has the highest HTHS of 3.1. Test oil gray is slightly lower HTHS, yet it has better wear metal control, although similar. And then test oil beige does have a lower HTHS and higher wear metals. So that one is a little more intuitive as far as the results that you see. Either way, though, all of these oils have demonstrated very good wear control in the engines with low wear metal accumulation. So just in summary, when we look at the results, we see that test oil gray has demonstrated better maintenance of viscosity, which in turn should deliver better maintenance of fuel economy potential. Because remained in the SAE 20 region during the run, while test oil bay trended upwards into the SAE 30 region, which means it may have reduced its fuel economy potential. With regards to TBN and TAN control, test oils bay and gray and beige have demonstrated excellent TBN retention and TAN control relative to the FA4 test oil. Now, the strong results for these 020s may have been enabled by the Group 3 base oil content. With regards to oxidation, test oils gray and beige demonstrated excellent oxidation resistance relative to the FA4 10W-30 test oil. Strong results, again, may have been enabled by the high quality base oils. So the base oils you use to formulate your product are quite important when it comes to what the oil can do in terms of performance. And ironware metals, well, we see that test oil gray produced ironware results better than FA4, while test oil beige were directionally the highest. But the main thing is we have demonstrated with on-road field trials under extreme maximum loads that solid engine protection is possible with a 0W-20. And that concludes my presentation. Thank you for your time today. And if you have any questions, please enter them and I will do my best to answer your questions. So thanks again.
Thank you so much, John.
Oh, you're welcome.
I will open it up if anyone has questions. Definitely you can go into the Q&A or the chat and one of us from the executive will view it. But yeah, no, both presentations are very good and it's interesting to see just, I guess, using the gray and beige to see which one actually did a better run overall. So
Yeah, we were pleased that that they both showed protection. One was a little bit better than the other, but that's sometimes to be expected. You know, and these were first-time trials. Some of the risk was, as I said, like eliminated, you know, using some proven technology, proven additive technology. But we were very pleased to, you know, to see that this was that we could do it. And you know, the way HTHS relationship works, that we believe that this would be an enabler to improve fuel economy relative to what's in the market today.
no, it definitely showed that. Anyone else from the executive with some questions?
Yeah, John, I have just a quick question. Throughout the field trial, would monitoring of the in-service high temperature, high shear be part of that protocol?
No, we didn't monitor HTHS because my understanding is that basically, you know, we did monitor kinematic viscosity. So at least we had a handle on what the kinematic viscosity was. But the HTHS wasn't monitored. If the kinematic viscosity had fallen and we got concerned about it, then we might have tested the HTHS as well. I know that HTHS, as far as the equipment goes, it's a little more finicky about using used oils as opposed to fresh oil. And so you kind of only test a used oil for HTHS if you have to. It's a great question, but I don't traditionally see it tested with field trials, but kinematic viscosity is almost always tested with field trials.
Sure. Okay. Thanks.
I think you must have answered everyone's questions.
It was that good. All right.
So, but if there is questions after this, definitely feel free to email the executive here, and we will definitely be forwarding them over to John. Oh, something just popped up here. From Don, was the test in an engine required FA4 oils?
No, these engines were built back in when the CJ4 category was going on. And that's actually the nice thing is that it's actually almost our preference to test these where FA4 is not recommended, because we can prove that even in applications where higher viscosity oil, like the CJ4 category or CJ4 category, it was, that was the oil at the time that the engines were engineered. We like to be able to prove that these oils are robust enough that you can actually provide protection in applications where a higher viscosity oil was the recommendation.
Don says thanks.
You're welcome.
And Jerome, why is a synthetic oil not used during the test to evaluate the performance versus group 3?
Well, synthetic, it's a little bit of a gray area as to what you actually would call synthetic. We actually are comfortable calling group 3 synthetic. And the additives that we used anyway for this were designed more for group 2, group 3 type of base oil. And if you went to a PEO synthetic, you may be going a little into the unknown as far as what the synergy of this additive with a PEO type would have been. I think group 3 did what we're doing here in group 3 was pretty good. If it had been a different viscosity grade, then we may have been forced to use more synthetic content. So for example, if it was like a 0.30 or 0.40, you would need more sort of high performance group 4 type synthetic. But these are the base oils. We use base oils these were all Petro-Canada base oils, so we like to use our own in our products where we can. And you could, and as I mentioned, synthetic is a vague enough term that you might, in most, I think for probably most oil marketers, group 3 and group 4 are synthetic in their terms anyway.
Okay, and Jerome has a follow-up is there a plan to have a full synthetic oil once approved?
Well, we don't actually really have any plans to commercialize this. So this was all an R&D effort. This is our research. This is what we do. We are looking forward to what the next category might introduce. It hasn't been defined. It hasn't even been proposed yet what PC12 is, but we like to see that we can sort of position ourselves to be ready, take some leadership in showing what we can do today that might, be relevant tomorrow or relative to what else is in the market. So, but there's no actual sort of, it's not that we can't, but we don't have any plans to sort of commercialize this. This is more just a demonstration of it than anything else.
And then Doug Rolls has a question. I'm interested in why the FA4 oil was a group 2 oil.
Sometimes the base oils that you choose are what you need for the application. So the FA4, it was a 10W30, and it's easy to formulate a 10. Well, it's a 1030. It had some group 3 in there. It can't tell you exactly how much group 2 and group 3, but it was mostly group 2. But it's fairly easy to formulate a 10W30 with group 2. You don't have to use group 3. You can if you want, so that you can technically call it a synthetic blend oil. So in the case of a 0W-20, because it's a 0W, the low temperature performance requirements are quite a bit lower than what the FA4 1030 requires. And when you do need those really low temperature performance, so for example, a 0W oil has to be able to cold pump at -40 Celsius. And a 10W at -30. And so that's quite a difference as far as low temperature pumpability, and then also low temperature cranking go. And so the way I look at it is you use synthetic or higher quality group base oils where you need to use them. So the 10W-30, you don't need quite that performance to meet the low temperature and high temperature requirements specified by that grade. But when you get into low temperature, like really low, like 5W, but even lower at 0W, group 2 base oils are not going to do the job. They're just not robust enough and to be able to meet those low temperature requirements. So the way I say it in a nutshell is you use the oils that you need to meet the requirements of that grade that you're shooting for, that you're formulating to.
Right, thank you. Any other questions? I'll give it another minute here. But yeah, no, I definitely want to thank you, John. This was a good presentation.
Oh, thank you. Well, thank you for having me today.
Okay. As I mentioned, if there is questions after this, definitely feel free to send an email over and we'll make sure that John gets it and he can get back to you with a response on that. Otherwise, I will say thank you so much to everyone who joined us. Our next meeting, I already forgot which date, it's October 19th. And that will be at 10 a.m. and a Zoom meeting as well. So thank you, everyone. Have a great day.
Thanks very much.
Awesome. Thanks,
Take care.
John.
Bye.
My pleasure.
Bye.